Once again, ladies and gentlemen,
the room
the
as we are
program will
about to
begin
start the
tomorrow.
event. Thank
Let's
you for
kindly
your
start
kind
our session for
attention.
your kind attention.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. It is my pleasure to welcome our distinguished guest, Bapak Asep Hidayat PhD, Head of the Research Center for Ecology BRIN, our honorable guest, Mr. Ping Yewardana from IIASA Episteme Project Coordinator, Professor Gilberto Camara from Episteme Brazil, Senior Researcher at INPE, our keynote speaker for today's expert talk, Ibu Henti Hendalastuti Rahmat PhD, Principal Investigator of the Research Center for Ecology BRIN, and moderator for today's session. We would also like to warmly welcome representative from IIASA International Institute for Applied System Analysis, C4 ICRA for Agroforestry, World Resources Institute WRI, Episteme Brazil, research groups and teams from the Research Center for Ecology BRIN, as well as academics, practitioners, collaborators, and all participants joining us both on site here at BRIN Cibinong and online via Zoom and YouTube. Praise be to God Almighty for allowing us to gather here today in good health for the first expert talk. Welcome to the scientific seminar entitled Earth Observation Data Cubes for Reproducible Land Cover Mapping, Lesson Learned from Brazil, held on Monday, May 18, 2026 at the ICC Building, Sukarno Science and Technology, BRIN Cibinong. This event is organized as part of the evolving Participatory Information System for Nature-Based Climate Solutions, or EPISTEM, by C4 ICRA World Agroforestry, Indonesia, in collaboration with the Research Center for Ecology BRIN to strengthen collaboration and capacity building in landscape monitoring technologies using remote sensing and Earth observation data cubes. We are delighted to welcome all of you and truly appreciate your presence and participation in today's event. It is a pleasure to see you all here. I am Restu Nur Afiati, and I will be your master of ceremony for this exciting event. Before we begin, please allow me to share several brief announcements. This event will be conducted in a hybrid format and broadcasted via Zoom and YouTube. Online participants are kindly requested to mute their microphones during the session. The Q&A session will take place after the keynote presentation. Participants joining via Zoom are also welcome to submit their questions through the chat box. Finally, we kindly encourage all participants to stay until the end of the event. Today's agenda will include welcome speech, opening remarks, followed by the presentation of appreciation, group photo session, then keynote presentation and discussion session, deep dive discussion and concluding remarks, and lastly, the closing and networking session. Ladies and gentlemen, we will now begin the event with the welcome speech from Bapak Asep Hidayat PhD, Head of the Research Center for Ecology BRIN. Please welcome Bapak Asep Hidayat PhD.
Tes. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Nama Budaya, Salam Kebajikan. Before I start a welcome speech, please allow me to share a short pantun. Matahari pagi bersinar hangat, berjemur sendiri di tepi hutan. Ilmu dirajut memperkuat semangat, alam lestari menjadi hangat. Bapak Ibu sekalian, mohon izin mungkin nanti saya akan menyampaikan beberapa hal terkait dengan welcome speech yang memang ditugaskan oleh MC ya, Ibu Restu. Sebelumnya saya akan menyapa Bapak Ibu sekalian. I will speak in Indonesia first, Professor. Ya, later maybe I will speak in the English. So first I would like to greeting someone stand here. Pertama saya ucapkan terima kasih atas kehadiran. First I would like say thank you very much for my friends Mas Andre. Beliau adalah Direktur Ikrab. Tepuk tangan untuk beliau. And also Ikrab team, maybe someone here stand. Thank you very much for your attending. And also I would like to say thank you very much for the coordinated project Epistem in Indonesia, especially Mas Doni. Thank you Mas Doni for your come. And I would like also say thank you to Dr. Ping. Thank you very much for your attendance here. And I would like also thanks to ad hoc team, our research center, for attend in this meeting. And also I would like to say thank you very much for researchers, as according to invite our letter to you, and then you can come in this room. I say thank you very much. And all participants in offline or online platform, thank you very much. Actually, I would like also say thank you, especially from the guest lecturer from National Institute for Space Research, Brazil, Professor Gilberto Camara. Thank you very much, Professor. On the behalf of the Research Center for Ecology, National Research and Innovation Agency, or BRINS, it is my great pleasure to welcome all of you of the first Expert Talk 2026. This event is part of our regular scientific discussion to strengthen collaboration, exchange knowledge, and promote innovation in ecological and environmental research. Today, I honor to be host an important discussion with the title Earth Observation Data Cube for Reproducible Land Cover Mapping, Lesson Learned from the Brazil. We are also very privileged to welcome our keynote speech. Once again, I would say thank you for Professor Gilberto Camara, Senior Researcher in National Institute for Space Research, Brazil. He also the project leaders for Epistem in the Brazil. That's right, sir? Maybe this project is including about the evolving participatory information system for national based climate solution. And also later, Mr. Ping also will give us opening remark. Thank you, Dr. Ping, from your coming again. He come from International Institute for Applied System Analysis. And this session later will be moderated by Henti Handalastuti Rahmat. She is the senior researcher from the Research Center for the Ecology, BRIN. Ladies and gentlemen, this expert talk is also made possible through the strong collaboration between Research Center for Ecology, BRIN, Center for International Forestry Research and Wood Agroforestry, and also International Institute for Applied System Analysis. We highly appreciate this partnership in the advancing scientific cooperation, knowledge sharing, and innovation to support sustainable ecosystem management and climate resilience. Land cover mapping has become increasingly important, especially addressing global climate change. And according to the IPCC, land use and land cover change contributed significantly to greenhouse gas emission, biodiversity loss, and ecosystem degradation. Accurate land cover maps are essential for monitoring deforestation, carbon stock, ecosystem restoration, urban expansion, agriculture change, and disaster risk management. Today, governments and researchers rely heavily on land cover information to support climate mitigation policies, carbon accounting, sustainable land management, and future natural-based solution. Without reliable and updating land cover map, it's become difficult to measure environmental change and evaluate the effectiveness of the climate action. However, producing up-to-date land cover mapping is not easy task. There are many challenges, such as their very large volume of the satellite data, different in image quality due to cloud and atmospheric condition, variation in classification method, limiting computing capacity, and difficulties in ensuring reproducibility and consistency across time and region. In tropical countries such as Indonesia and Brazil, cloud cover alone can become a major obstacle for continuing observation. Brazil has become one of the leading countries in development innovative approaches to overcome these challenges. Through the institution such as National Institute for Space Research has advanced the use of the Earth Observation Data Cube with organized massive satellite dataset into analysis ready structure. This approach enables faster processes, reproducible workflow, long-term monitoring, and more transparency land cover analysis. This innovation support not only scientific research, but also practical application for environmental governance, forest monitoring, agriculture, and climate policy. Therefore, today's discussion is very relevant for us, especially from the Indonesia, continue to strengthen environmental monitoring system and development scientific-based policy for sustainable development. I believe this expert talk will provide valuable insight, lesson learned, and opportunity for future collaboration between you as the researcher, institution, and also countries. Finally, I would like to express our sincere appreciation to all speakers, organizer, moderator, and participant who has joined this event. Before the close my welcome remark, I also will finish with the short pantun. Burung merpati terbang melayang, hinggap sejenak di pohon kasuri. Mari menjaga alam tersayang untuk masa depan bumi lestari. I wish all participants are fruitful in inspiring discussion. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Om Santi Santi Om. Terima kasih. I give the time to the MC.
Thank you, Bapak Asep Hidayat PhD, for the inspiring welcome speech. Next, we would like to invite Mr. Ping Yowardana from IIASA EPISEM Project Coordinator to deliver the opening remarks. Please welcome Mr. Ping Yowardana.
Oke, udah Pak. Terima kasih kepada MC. Selamat pagi Bapak Ibu sekalian. Salam sejahtera, salam penuh keselamatan, rahmat dan berkah. nama saya Pingyowardana. Saya datang dari lembaga riset yang namanya IASA, International Institute for Applied Systems Analysis. Kehormatan dan senang sekali bisa di sini pagi hari ini untuk bersama-sama membuka kesempatan expert talk di PRE BRIN, Pak Asep. Pertama-tama saya ucapkan terima kasih kepada PRE BRIN, kepada Pak Asep Hidayat selaku Kepala Pusat PRE BRIN. Terima kasih banyak Pak, tidak hanya untuk kesempatannya di pagi hari ini, tapi juga untuk kolaborasinya di kegiatan Epistem. Seperti yang tadi Pak Asep sampaikan, kami kurang lebih sekitar satu tahun lebih dikit ya Pak ya. Belakangan ini sudah bermitra melalui bantuan dari koordinator untuk kegiatan Epistem di Indonesia, ICRAF Indonesia. Kami senang sekali bisa melakukan kolaborasi yang begitu dekat dengan aplikasi dan dekat dengan kompetensi penelitian di Indonesia. Dalam kesempatan ini saya juga ingin berterima kasih kepada tentunya rekan IASA di Indonesia, pada ICRAF Indonesia atas kerjasama yang tidak hanya solid secara teknis tapi juga penuh dengan stakeholder engagement yang sangat efektif dan sangat impactful di lapangan. I will now switch to English, Pak Asep, just to facilitate the discussion a little bit, if that's okay. So I'm very happy to have the opportunity of facilitating this discussion. I hope this is more of an exchange actually than it's not an expert talk, but I think it's experts talking to each other. We are now in the National Research and Innovation Agency. I think this is really the home for Indonesian experts that have been working for an extensive period on the topic. And we are very lucky and happy to have Professor Gilberto Camara from the National Space Research Agency in Brazil. I think Professor Camara brings a lifelong experience, not just in technology development for forest monitoring and Earth observation, but also in applying that and having a very close interaction between the results of technology development and policy application and enforcement for land use policies in Brazil. Clearly, Brazil and Indonesia are both tropical countries, but with very different geography, with very different socioeconomic conditions, with very different challenges as well in the implementation of land use changes and land use policies. So this is a wonderful opportunity to really, go on both sides of technology development and implementation and how it is addressing and its relevance to policy application. So I think that is also why in the agenda we have roughly an hour presentation or lecture, so to say, from Professor Camara, but it's followed with another hour of discussion. So it puts in the same weight in exchanging not just learnings, but also really intensive discussions between our guests from Brazil and Bapak Ibu sekalian present here in BRIN as well as online. So I think I won't take too much time, Pak Asep. Once again, thank you very much to PRE BRIN, to colleagues from ICRAF for making today happen, and I very much look forward to the lecture and to the discussion that will follow soon. Thank you very much, Pak Asep, Bapak Ibu sekalian.
Thank you, Dr. Ping Yuargana, for your remarks and insights. Ladies and gentlemen, we would now like to continue with the presentation of appreciation to our keynote speaker and collaborating partners from IIASA and C4ICRIVE for their valuable support and collaboration in today's event. May we kindly invite Professor Gilberto Camara, the representative of IIASA, Mr. Ping Yuargana, C4ICRIVE, Bapak Andre Eka Dinata, to please come forward. We would also like to invite Bapak Asep Hidayat PhD to present the appreciation. Thank you. May we kindly ask all distinguished guests, representatives, and speakers to remain at the front as we will continue directly with the group photo session. May we kindly invite also our moderator, Ibu Henti Hendarasuti Rahmat PhD, to please come forward for the photo session. And we would also like to invite all on-site participants to join the photo session. For participants joining us online, we would also delighted to include you in the group photo session. May we kindly ask all online participants to turn on your cameras for a moment as we take a screenshot for documentation. Thank you for your participation and cooperation. Thank you everyone for joining the group photo session. Ladies and gentlemen, we are now entering the main session of today's expert talk featuring Professor Gilberto Camara, a globally recognized expert and one of the pioneers in the field of satellite image time series or SITS for Earth observation data analysis. We are truly honored to have him with us today to share his knowledge and experience. To get us through the session, I would like to hand over the session to our moderator, Ibu Henti Hendarasuti Rahmat PhD. Please welcome Ibu Moderator.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable Head of the Research Center for Ecology, our collaborators from IASA, Bapak Ping, our partners, ICRAP, Wood Agroforestry, and also Wood Resource Institutes, and Epistem Brazil, invited speakers, practitioners, researchers, and all the participants who attend this expert talk. Thank you very much for your attendance today for our first expert talk hosted by Forest Research Center for Ecology today, Monday, May 18, 2026, with the titles and our keynote speaker, Professor Gilberto Camara. Before I proceed to his presentation, please allow me to read his short biography so that we can deeply appreciate how his expertise will bring new insight for all of us. Could you please, Mas Lutfan, maybe for our audience in the online Zoom, maybe you can show Bapak Professor Camara short biography. Professor Gilberto Camara is a leading Brazilian researcher in geoinformatics and earth observation. He is currently an associate researcher at Fundação Getúlio Vargas, hope I do not make a mistake in pronunciation, and emeritus researcher at Brazil National Institute for Space Research, or INP, where he works for 35 years. He served as the INP's director from 2005 to 2012, and later as a director of the Secretariat of the Intergovernmental Group on Earth Observation from 2018 to 2021. He is internationally recognized for promoting pre-access to geospatial data and setting up efficient satellite monitoring of the Brazilian Amazon rainforest. Cited over 9,500 times. He has also received numerous accolades, including the Pecora Awards from NASA USGS, and being named a Commander of the Order of Scientific Merits in Brazil. So, ladies and gentlemen, we are truly fortunate to have Professor Camara with us today. Thank you, Professor. This session will be divided into two parts. The first 60 minutes, I would like ask Professor Camara to please present your experience and your works and your knowledge, and later of that, after finishing the presentation, we may have a discussion for about 60 minutes also. So without further ado, I would like to give Professor Camara, the stage is yours. Thank you.
Hello, good morning. Salam alaikum. Okay. So, Can you hear me? Okay, I just want to avoid the echo here. And let me see if I'm sharing the screen. Just a second. I think I need to share the screen. Share. See if it works. Okay, and I would like to leave this here and share. Okay. So let me just move a little bit so I'm not in front of the screen. Okay. Well, I'm very much honored with the invitation from Bryn. Thank you very much. From ICRAF and from YASA to come here to Indonesia. It's always a pleasure to come back here. Been here twice, and it's always enormously enlightening to be here. It's a fantastic country with huge potential and a lot of talented young researchers such as you. So for me, it's really a pleasure to be able to speak to you and to share some of the experience. Madam Moderator, let me ask you, do you want me to take questions during my presentation, or you prefer to take questions at the end? Excuse me. Excuse me.
Sorry.
I am asking you if you want to allow people to put questions during my presentation, or do you like them to take questions in the end? What is your advice?
So I think to make a complete outline for all of us, maybe because this is very new to us, maybe you better complete your presentation, then we can discuss later for question, answer, and other discussion.
Okay. Very good. So I'm going to speak from the point of view of the fact. Can you all understand my English? Yes, I'm trying to speak slowly. Of course, I'm not a native English speaker, so somehow I hope that my pronunciation gets across to all of you. Okay? Fine. So what is happening is that all of those researchers who work on environmental sciences have now a very much opportunity to access data which was previously out of reach. For many years and decades in remote sensing, the data from satellites was not available or was available at a full price. And it was meant to be very difficult to access the data. So since 2005 and then 2010, many of the satellites have either made themselves public or they have been built as public data. And this includes satellites, I hope that you have heard of them, all of them, the Terra, which hosts the MODIS sensor, Sentinel-1A and now 1C from the SAR, from the European Commission, Landsat 8 and 9 and 7 and 8 and 9 from the US Geological Survey and NASA, Sentinel optical data 2A, 2B, 2C, there are 3 satellites up there now, Sentinel-3 from the oceans, and also you may not have heard of this one, but this is CBERS 4 and 4A. These are 2 remote sensing satellites built together by Brazil and China, which are operating and produce images, and whose images, of course, of Brazil are available. Now, the question which is as follows. The data from these satellite missions is being made available at various cloud services. I'm going to talk about some of them today. These data sets can, in principle, be used for what we now call machine learning. Of course, they can be used for visual interpretation as well, but being lots of data, it's hard to do. We are capable as humans of providing a very good interpretation visually of a single image. It's much more difficult for us to provide a visual, detailed interpretation of 200 images. So when we have a lot of data, it's inevitable that we would like to use machine learning techniques to be able to process that data. So the point here, the question I'll try to address, is how do you first access data on cloud services, one. How do you transform this data such that that data is useful and possible for machine learning? And three, what are possible options for centers like BRIN to deal with the question of cloud services? The first thing that you will notice is that I'm going to start with the definition of what we called Earth observation data cubes. So the logic of a data cube is very much thought of as, the word data cube came from your neighbors Australians who, let's say, abstracted the idea of the same area being available in multiple times. So the idea of a cube in the sense here is that you have the surface of the Earth, an area or small or big as Indonesia, for example, and covered many times in the sense that you have a regular coverage of it, and so you are able to recover information about change in different instances of time. Now, this data set, as I said, is a conceptual vision. Now, if you go, and we're going to show some examples, if you go to a cloud service, and I'm going to talk a little bit about the cloud service nowadays, the data is not organized nicely as data cubes. So if you now are, and then the clouds, and then let me give you some examples of clouds. Let me just change a little bit one thing. Okay. Just to get the right order. Right. So the first question is, what is a cloud service? A cloud service is a collection of data which is put together either commercially or freely by a data provider. So this is not necessarily, in the case that we have, is not the data agency, the national, for example, European Space Agency, that is a cloud provider. Cloud providers are organizations which pick up data from different sources, and they organize the data for you. I'm sure that you are familiar with Google Earth Engine. I imagine that all of you are familiar with Google Earth Engine, right? Is there anyone who doesn't know? So, technically speaking, Google Earth Engine is a service for processing. It is not a cloud provider in the sense that I cannot get data out of Google Earth Engine, and also in the sense that we see that it doesn't contain data cubes. So it contains data, but you cannot access it. However, if you go to a provider such as Microsoft Planetary Computer, okay, it's different because the data available in this cloud service from Microsoft, it is available for accessing, and it is accessible online. So you have, for example, harmonized Landsat and Sentinel collections, Landsat, MODIS, Sentinel-1, Sentinel-2, lots of data sets. And you say, okay, what good does it do me if Microsoft has this data? Well, the difference here is that you can access it. And through this lecture, I'm going to present some examples which we have developed in Brazil in a package which runs in R and Python, an open source called SITS, which stands for SITS. So this is a package which was designed for general purpose users to access data and process data from cloud services, transforming them into data cubes and using them for machine learning. So our inspiration was the idea that you can pick up the data, organize it in a data cube, and process machine learning with it. So let's first consider what are these collections. So these collections, as I said, there are many around the globe, some general, some specific, and I'm going to give a general tour of these collections just that you get the feeling of it. So normally, how much are you familiar with the organization of data from Sentinel-2, Sentinel-1, and Landsat? Are you familiar with it? Okay, just for the record, Sentinel-2 data sets are available in an organization we call a tiling system. The Earth is cut into a tiling system, which is called MGRS, Military Grid Reference System. This tiling system is designed by the American military, and it's used to, so the images, ESA processes the images and gives them into this tile system. So it cleans basically what ESA does. It basically cuts the images, makes them available inside these grids, and gives them and you can access Caesar or you can access a data provider. The same for Landsat. Those who are more familiar with Landsat knows that Landsat has another type of grid, which this is path-oriented by the satellite, and it's called World Reference System. And again, when you pick up a Landsat image, for example, in Google Earth Engine, it is organized as by this World Reference System. Now, how many images collections are there? A lot. I'm going to show you some examples. For example, I'm going just to show, and I have the R code here, but I want to be quick because we don't have much time. So here, someone says, I want to access the data which is available on the Sentinel-2 collection of Amazon Web Services. In this collection, I want to select a certain region, like a tile. I want to select some of the bands. I want to select a temporal interval. For example, this is very short interval, a month, but I could select a bigger interval. So here, what I'm saying is the data from Amazon is accessible and downloadable. So this is Amazon, and when you plot the data, by the way, before I see, this address here, I'll pass it on to you if you want. I don't know if you want to follow online, but the easiest thing is to, okay, so this, I'm gonna bring up, just that you get the addresses. So if you want to note down the addresses, okay. Oh, come on. Okay, so this is the address where the software is available in GitHub. And this is the address where this online book is available. Okay, so I will be showing examples from this online book, but everything is available on the web. Okay, fair enough. So now, what I'm saying is that, you can, because of they have adopted a protocol, you can access these cloud services such as Amazon Web Services, and you can access them for Indonesia. So you can get this data for a whole of Indonesia if you want, for the bands and for the catalogs like Sentinel-1, Sentinel-2, Landsat, and so on. And this same goes for Microsoft. So Microsoft, for example, which is I think the best global services, has different collections of Sentinel, like Sentinel-R. This is the radiometric correction, Sentinel-2, which is the Sentinel optical data, Landsat, the whole collection of Landsat, DEM from Copernicus, MODIS data, and the harmonized Landsat satellite images. So you would do the same. For example, you say, oh, I want to get some data from Microsoft. So I would go there, access the Sentinel data from these tiles or this region of interest, get some bands, get some start date, and I, of course, can start working with it. So this is, Microsoft has Landsat, so this is one example of getting a Landsat data from Microsoft. This is one example of getting a Sentinel-1 data. So you say, oh, I want to get the Sentinel. This is the ground reference data. This is unradiometric corrected. This is the standard base product in the VV band, in the descending, in the styles, and the start date. And you get, this is where you get the Sentinel. So one thing that you see already here is that this organization here corresponds exactly how the SAR satellite basically views the data. If you remember a SAR satellite and an optical satellite, they differ by the way they acquire the data and, of course, the sensors they have. An optical satellite has sensors on top and looks at the bottom, at the nadir, as we say, whereas a SAR satellite sends signals from the side. So typically a SAR satellite would send signals from this orbit, and then it receives the backscatter and measures the backscatter. It's an active sensor. And it always looks either one side or the other, depending if it's going from the North Pole to the South Pole or from the South Pole to the North Pole. So here you say, oh, but this is cut like this. This is a kind of fuzzy. This does not help me if I want to join this satellite, for example, with the optical satellite. So if I want to join the two data, the data sets which are available in the cloud services are not sufficient to give me the organized, nicely aligned Sentinel-1 and Sentinel-2. And this is because they basically, these cloud services basically get out the data as the agencies give to them. It's the similar situation as you go for Google Earth Engine. The data is there, but it is not necessarily organized in a nice way in what we call the data cube. So now you have data available. You can download the digital elevation model. Oh, I want the digital elevation model. Yes, you can get that. Oh, you can, I'm going to talk about Brazil Data Cube later. You can download the Sentinel-2, and there's also another provider called the Copernicus Data Space Ecosystem. This is maintained by the European Commission, and of course you don't pay for access to data as well, so you can obtain the data from the European Commission. Okay, all of that, and there's other providers here. So I'm making the case that there is lots of data out there, okay? But the data that you get out there is free, but it's not necessarily organized in the nice way we would like to have to produce analysis. It's certainly not organized as data cubes. The jargon that the community uses to refer to this data is analysis-ready data. It's a little bit misleading because you would think, oh, the data is ready to be analyzed. But in practice, it's not so easy because the kind of data you get, it's like this. So imagine these are different time instances of the same place. The data that comes may come just a part of it, and with the all clouds information, so you don't take out the clouds or you don't clean things. And the neighbor of its data, if I want the regular, may not be available in the same timeline as this one. So we would like to say that when you have what we call an image collection, which is what is available in the data providers, Amazon, Microsoft, Copernicus, Google Earth Engine, what you have is this here. And normally you would like to have your data nicely organized so that I say, okay, out of list data, I want this nicely organized data. So, for example, I have one clean data, or the cleanest possible data, in a 15 or 16 date interval or a month interval. So there is a process of creating a data cube which the agency, BRIN for example, who is in charge of the data needs to do. Is it clear up to now? So the data is there, but it's not ready. You still need to massage it and organize it in such a way that it can really be matching like regular in space and in time. And this is a process which we call regularization. It's a big name, but it's a name that shows what is happening. So this is an example from accessing a data on Amazon Web Services and from the Sentinel collection with two neighboring tiles, so two neighboring regions, one, so you can think of one part of Java and the next part of Java. And I select some bands here, and I select some dates here, start date and end date, so I have a sequence. For example, in this case, basically 2 months, the end, so the beginning of July to the end of August. And then when I ask the system what we call the timeline, what is the timeline? It's the time of the data passage of the satellite. And then you find out something interesting. It is not a given that, and it's not something, the satellites don't pass in two neighboring regions in the same day. So when you get like collections such as this one here, and you say, I want one images from here and the neighbor, you don't necessarily get the images from the same date. The satellite is passing, the Earth is moving, so the image from the neighboring region may be acquired at a different date. That's geometry, and that's the way the satellites operate. So when I plot the timeline for two neighboring tiles, what I get is two different timelines. For some reason, because of geometry, dates, acquisition dates, and satellites, one of the areas, one of the neighboring tiles, has 12 acquisitions in the same period. So this is beginning of June and beginning of July, end of August. And the neighbor has 21, 22, 23, 20, 23, 24. 24 acquisitions. So how do you combine two satellites or two images, two sets of images, if their timelines are different? It will be inconsistent from the point of view of my analysis. And even in, for example, one of the timelines here, it may be that the satellite is passing, as you know, the satellite passes from north to south, the Earth moves, and the satellite not necessarily covers the whole area. It may cover only a part of the area. So again, the data you have out of the blocks or out of the cloud services is like this. It's not complete. So when you sort of regularize, you basically say, well, I want a composite image every 16 days. Those of you who have used Google Earth Engine are familiar with the term geomedian. Who knows what a geomedian is? Have you used the geomedian in Google Earth Engine? I think most of you, if you use, are you regular users of Google Earth Engine? Yes? No? And how do you select, you take one image or you take the average of, normally when you do, a lot of people use Google Earth Engine, a lot of them take the average image for the year. Right? Huh? Sorry, please louder. Yes, yes. Yeah, so you in order, because the image collection is, you use a mean value from the image collection. So this is called the geomedian. Yeah, okay, it's the same. You take the mean value. But the problem here is that you can think of the mean value again, you may get the mean value, but it's not necessarily the best arrangement with data, and not necessarily, normally when you take a geomedian or mean value, you take over a 6-month period or a 1-year period. It's less common that you take over a monthly period. So normally, users of Google Earth Engine normally deal with yearly images or month or semester images or something like this. Whereas here you are aiming for the best possible time difference that you can have a composite image from Sentinel. Why is that? Okay, once you have a regular set of images, then you can start thinking about the, let's say, the contents of a data cube. So now you produce the data cube. Now, technically speaking, a data cube is a multidimensional array with 4 dimensions, regular dimensions: the latitude, the longitude, the time, and the attributes. And if your data cube is built with a certain regular interval, you can extract from the data cube the temporal patterns, the time series, which when you compress 1 year collection into a mean, you lose the ability to understand changes that happen during that year. So by having the time series, you are able to, this is for example in the case of Modis, which is even better because the Modis products are regular already. You can see, for example, the temporal variation of, in this case, this pixel, and you can see that this pixel, you see the variation of the NDVI typically associated with temporary agriculture. It is a signal where the NDVI starts low and then goes high and then cuts and starts low and then go high. So you see an example of an agricultural practice where you have one or maybe two, in this case two, crops per year. Where here you have a typical signal, there's some noise here, but you can see the typical signal of a forest. So you get, this is a 16-day time series where you, over a period, for example, of 16 years. And this is a pixel which has been mostly covered by forest during the whole period. And finally, you have a third kind of pixel, this example, where it started being a forest, it was converted into pasture, and then it went into agriculture. Let me get this example in more detail. Here. Where is it? Here. Okay. So here it's that pixel in more detail. So here we have, this is 23 years, from January 2001 to the end of 2022. And this is the Modis time series. So from 2000 to 2003, the time series is a forest. So it's clearly a stable signal. And suddenly the signal collapses very strongly, where the sign of deforestation has taken place. And then for a number of years, from 2004 until 2012, there is this, you can see like a sine wave every year, which there is this curvature. It starts low and goes high and low and high like a wave. And this time series is typical of an herbaceous species, because the herbaceous species, they dry in the hot months, and as soon as you get some rain, it becomes green and then goes back again. So they follow the cycle of the stations and follow slowly as the precipitation and dryness changes. But then there is another change, and this other change happens in 2013, where you see a series of peaks and troughs, very steep peaks, and which is typically associated with temporary agriculture. So this is an area very typical of that region of Brazil, where it started as a forest, was deforested, then converted into pasture, then converted into temporary agriculture. And that allows us to use time series effectively in many situations where you have, in tropical countries, very typical situation is where you have seasonal changes. This is an example. This is a dam in Brazil, in the Amazon, which was very badly designed. It's badly designed because it basically, there was a river which was dammed, and the dam is more or less here, but it was badly designed because it dries completely in the summer months, in the dry months. So this is the same place. And of course, if you collapse the image, if you take the mean over the whole year, you lose the information of course, of the dry and wet seasons. If some of very typical forest and typical tropical things like seasonal forests, wetlands, temporary agriculture, they become much tougher to analyze if you don't have the time series. So the idea of data cubes and time series go together. You build the data cube and then you allow the time series to be accessed. So this is the interesting part on the data cubes. Now, you may argue, okay, so what? So what? Well, one simple thing that having data cubes organized allows you is merging data. If your data cube is nicely geometrically and temporally organized, you can, for example, merge Landsat with Sentinel. I have just one example here. This is an example where you take a Sentinel-2 image, okay, from a certain tile, and you plot that image. So this is like color composite, standard color composite, with blue on the second band 2, and band 8A green and red. Fine. But, okay, that's just the Sentinel. But then you say, okay, now I want the image, the SAR image for the same area, because I want to use a SAR and optical together. Now, when you download the data from the cloud provider, you get something like this, tilted, because that's the way the satellite data from SAR comes. Oh, but that doesn't help me a lot. So I have to create what we call a regular data cube for that tile. Okay, so I create a regular data cube for that tile and say, no, I want to cut this tile into exactly the tile of where I have the optical data, and then merge the two, and then I want a color composite, which is two bands of this color composite come from the Sentinel-2, the optical, and the blue is actually the VH band from the SAR, which you might notice gives a different information if you compare, for example, this is the optical color composite. This is the color composite with the SAR. And of course, you can do a lot, and you can process this data. And you can combine multi-temporal sources and so on. Well, then, not going to, one thing that you might want to do, whoops, oh, okay. is, okay, you have some data set from some area. This is your data set. And let's suppose you have some training data. Training data is something that you, as remote sensing experts, know it is the important bit where the local expertise is so important. Of course, that you need to select what are the classes that you want on that data set. And you need to select representative points on that. Of course, you need also tools that improve the analysis of that data, to which I'll talk if we have more time or if you have questions. But let us argue for the moment that you have, in this case, a number of classes associated with the area that we are working. So these are bare soil, burned area, clear cut with vegetation, forest, forest in mountains, forest on the side of the mountains, riparian forest, which changes according to the season, seasonally flooded areas which is flooded seasonally, water and wetland. And given that I have the data cube with the 16 days, I can more or less associate them with patterns. How do the time series look like? What happens, do we have a difference? Are there some differences between the burned area and the bare soil? And the answer is yes. Are there differences between the seasonally flooded areas and the forest? Yes. I mean, these are subtle changes on the time series which are useful to produce characterization and to help us in improving the quality of the resulting classification, different from an area which is basically if you have only one image. So in the end, what you have is, for example, now that you have your samples, and the samples are nicely organized, you can train a machine learning model, in this case, a random forest model. So now that everything is nicely organized, okay, I will train a model. In this case, a random forest model. And I can classify this model, use this model to classify a data cube for an area. For example, this is a data cube for a certain area in Brazil, and I am using a random forest model, and here are some details on how to optimize this for GPUs. And the output is a series of probabilities. It's normally the classification, the machine learning classification gives you as output for each pixel a series of probabilities. So you have 12 classes, you have 12 probabilities. Of course, the probabilities of each pixel add up to 1. And here, for example, for each pixel here, this is probability for class forest. So in other words, the colors here indicate The greener parts are the places where the algorithm thinks that forest is the more likely class, and of course, whiter parts are the probabilities that it is very unlikely that this is a forest. And this kind of data is very useful because then you can do a lot of things with it. One important thing here is reducing noise. Some people who have used directly classifiers like random forest and things like Google Earth Engine notice there is a salt. Have you ever noticed there is a salt and pepper? It's like someone has put salt, some pixels which are sort of strangely misclassified. Have you seen that? Typical, for example, what happens here? Very typical output here of these is something like this, okay, where this is a very typical kind of output from a classifier like random forest. If you ever have classified, you notice that it doesn't look right. How can these small areas be inside? And normally these are a combination of artifacts from the data, outliers, inaccuracies of the classifier, and so on and so forth. It's very typical. So you don't want this. You want something like this, right? Much nicer to process. And of course, you need some methods to what we call do some smoothing and remove the outliers. So there's a number of smoothing methods. I will not go again into detail, but that clean this data set. So basically you clean the outliers in order to be able to process the data and to output something more nice, clear. So zoom out. Okay, so back here. Okay. Whoops. Still, okay, good. So we are here. So the output, as I said, it's a probability map which you can clean. In other words, remove outliers. And after you have removed the outliers, then finally you can do something like, now associate, and that's the typical thing one does, for each pixel the most likely class, which results in a map like this one, where you have areas. Some areas are seasonally flooded, some areas are riparian, some areas are forest, some areas are clear-cut, and so on. Some areas are burned areas, and so on. This has an accuracy for the forest classes of 95%. So, back to the beginning, since we're close to our hour in terms of presentation. So, in the beginning, I said, where is it? One thing I said to you is this. The logic here is that data is out there, but it's not, the data is free, but nothing in this world, there is no free lunch. So you have to organize the data so that you can provide and do realize machine learning. Now, you mentioned very nicely, the director was very nice to us and mentioned the situation in Brazil. So what happened in Brazil is that we decided as a country to build a national data cube. So what we call the Brazil Data Cube is a service which processes data from Landsat, Sentinel, MODIS, and CBERS and delivers this data as organized data cubes. Instead of what Amazon and Microsoft do, which is the analysis-ready data only, it provides already organized data cubes. So it's a big work because it involves, of course, the fact that you have to maintain computer services, IT infrastructure, who has to run. The advantage is, of course, that you don't have to depend necessarily on American providers, and the advantage is that you provide our customers, universities, research institutes, government, with data which is really ready to be analyzed. So the data cube of Brazil is an institutional, it's done by INPE, and it is available worldwide. Of course, you would not necessarily, okay, this is it, Explorer. Oops, from Brazil, the BDC Explorer, okay. So you can have your Data Explorer and you can select your data, and using these software packages, you can download your data, but the difference between the Brazil Data Cube for Brazilians and the Data Cube, like the data services like Microsoft, again, is that the data is already organized. It's taking a little bit of time because of the internet. Maybe the connection has to go to various places until it reaches Indonesia. But I think it's almost time. I think I've covered the basics of what you asked for, and I think it's time so that we have an interaction of questions and answers, because that would be useful. So please go ahead, moderator, please.
Thank you, Professor, for your brilliant sharing of knowledge and also experience in your very interesting expertise. So for the discussion, I would like raise two questions from two attendee here per round. So please, if in this room who has a question, I can allow you to two questions per round. So I open first round first for the two questions. And please, you can first mention your name and affiliation, and make the question, please, maybe direct and straightforward also. Thank you.
Okay, thank you. Good afternoon, everyone. My name is Agil. I am from World Ecoforestry. And I would like to ask a question to Professor Kamara relating the cloud cover. As we all know, the tropical landscape regions, cloud cover is a very prominent challenges, and especially usually we conduct cloud cover mitigation by masking and using temporal aggregation, such as extracting the median value or the mean value to acquire the minimal cloud-free imageries. But how do you handle cloud in, especially in time series analysis especially in this package? Because I haven't seen how to deal those with the cloud cover. Thank you. That's my first question.
Thank you. That's
Professor, if you would like to more comfortable, if you sit in, please sit in. Or
okay.
just, yeah. So I think 2 questions, but maybe 1 question and then answer, and then I will open one again. I think that's better for us to understand our discussion. Please, maybe you may respond to Mr. Agil's question.
Okay. So the question here is, you have, very important question, you have 2 ways to deal with clouds, one after the other. The first one is to provide, it's a tricky thing to decide on what is the interval on which you guide to combine images. So in the example which is on the book, if you go back there, I hope you all can see here, we had this is an interval of 2 months, right? So we decided, say, let's take 16 days by which we have about, at minimum, 6 images in the later case and 12 images on the second case. So we look, if we have a 6 images per 16-day interval, you look at the most, because 16 days is sort of a magical number by which we think you can optimize the issue of cloud cover versus time series. So we take 16 days, which could have taken 1 month, but take 16 days and say, okay, within the 16 days, which is the most stable pixel? Okay, you take that. Now, even with 16 days, there still be places with all areas are clouds. But then you have a series of 23 data points, right? So again, when you picked up these 23 data points for analysis, now you have, some of them will have clouds, some of them will have not. And then again, you interpolate to get a smooth curve, or at least a continuous curve, to do the analysis. Now, that does not work everywhere, but even in a tropical country like Brazil, it has served us very well. Because you could use 1 month to improve, but it depends a lot on the area. It depends a lot on the area. As a last resource, you can combine Sentinel-1 with Sentinel-2, because Sentinel-1 is completely without clouds, which is another option to improve your readability. But there is no miracle here. But the problem is, if you lose completely, the clouds, if you completely lose your time information, you're going to end up, let me give an example from Indonesia. Just 1 second, please. If I have that. Yes, okay. So this is researchers from the University of Diponegro here in Indonesia, which published this paper called Leveraging Time Series Imaging Open Source Tools for Enhanced Land Cover Classification. And what they did, they produced two maps, one using Google Earth Engine, one using SITS. And then they measured the accuracy. The Google Maps had one image, the SITS had 16-day time series. And the accuracy is, they reported, we didn't even help the paper. We saw when the paper was ready. The overall accuracy is much better when you use time series. And here is the user accuracy of Google Earth Engine versus SITS for this area of Indonesia. And you have built up water body, paddy field, green corridor, mixed garden, plantation, and bare land. And you can see that in all classes, the time series algorithm provided better than Google. And this was, I have to check the paper, but an area of Indonesia. So it works. It's never perfect, but it is better than what we think would be if we compress time too much.
Okay, Mr. Agil, do you have any follow-up question? Wait.
Okay, thank you very much for the answer for the question. It's really encouraging. But I would like, so basically I would like to clarify a little bit. So instead of masking out the cloudy pixels that we often found in I guess an image collection, it's better to leave it there and process the image as it be and applied, let's say, a smoothing procedure to kind of refine the spikes of the pixel values that caused by clouds. Is my understanding correct regarding the topics?
Yes, I understand. I think you understood correctly. You have two issues. First, you try to find a non-cloudy pixel in a 16-day interval, which might have anywhere from 6 to 12 images. And then if you're not capable of doing so, you still try to interpolate points in series. And then after you finished the processing, you still have the option, like I said before, of doing the spatial smoothing, which is because in the case which the example I was showing, where is it? The example I was showing was that some, but not all, of the cases here there are many sources of noise in a classification. Some sources are the resolution, spatial resolution. Some sources are, for example, indirect effect of clouds, which may not lead to volume classification. So that's why you need, it's very useful not to take this as the final result. So on top of that, you will try to filter and then you use the, let's say, the local information from the neighbors to clean up. So there is still the possibility of, even with all those techniques, some of the areas will still be cloudy all the year. And then you have to go to Sentinel and try to use Sentinel-1 instead of Sentinel-2 to see if there is any contribution that Sentinel-1 can do. I hope I answered your question.
Thank you.
Thank you for the clarification. It's clear. It's good for me. Thank you.
Thank you. Thank you, Mr. Agil. I think your question is very technical, yeah, and you really now the material is maybe this your daily life, I think. So, is there any question are. Yeah, please.
Someone raised their hand in the.
Yeah, we also still has here in the class, and then we also go to the online, Professor. Please.
Okay, thank you very much, Professor Kamara, for your presentation.
Could you please raise up your
Okay.
voice?
My name is AN. I'm from Research Center for Ecology, and my question is,
You.
okay. My name is AN. I'm from Research Center for Ecology. Actually, I think this is such a cool package in art that you created, and thank you for making it available on GitHub, and especially for the art package. This is my first time knowing about the cube, because this actually can answer the question, especially in Indonesia, where we don't have satellite images available for all of the area. My question is, can you give us some example or maybe insight where the cubes is used in Brazil, for example in forestry or ecology? And I think it will be a great inspiration for us to learn from Brazil using the example from your country. Thank you very much.
Okay, thank you. Can you?
Let me just understand. You mentioned that Indonesia, you don't have the image. I didn't understand the first part of your point.
No, but sometimes the image is not complete.
Sometimes the image is not.
It's not complete. For example, from the presentation that you mentioned, we have the data for one area, and then the neighboring area is completely dark. I found it many times, but I think this maybe can answer such kind of difficulties that we face. So I want to know how the cubes is used in Brazil in real application, for example, in the national or maybe regional level.
No, just a point. I think I was not. Apologies because I was not clear here. It's not that the image is dark. Okay, let's look at it again because I think there was some misunderstanding here. What I said is that the data which is available on a cloud service is the data which is produced by the satellite. So if you take one date, say 33 of July of 2018 for this image, this is like 28th of July of, this is what you get. This is not what you get in the data cube. My point is, this is the data. Now, this doesn't mean that you're not going to have data here. This means that you have to combine data from a certain interval in order to be able to complete the missing areas and obtain something like this. So, but now you can do the same, I don't know if we have time, but we could try here and do the same for Indonesia. And then I'll first answer the second part of your question, so that you're talking about an application. So give me 1 second, and just a second. Is this? Okay, so this is so rapidly. Okay, since you mentioned an application in Brazil, so let me sort of describe this thing. As you know, Brazil has a long tradition of measuring deforestation, and the data comes from 1988. And it started using Landsat data and now uses Sentinel data. And usually this is done by visual interpretation which is very time consuming and of course requires a lot of resources. So the question we asked ourselves is, what are the challenges in developing a methodology using Sentinel-2 image cubes for deforestation classification in the Amazon? And then, of course, you want to know, the question that you want to answer is, when is a forest not a forest? So essentially, you want to see that there is a transition from a forest to a clear-cut area. And of course, this transition is, you want to capture this transition on time series. So this, for example, is an area, so here is the, in blue, that's the NDVI, okay? So up from, this is 1 year, but the year starts in August and ends in July. So from this period, there was a very sort of stable signal, and then suddenly the NDVI collapses, and you can see that on the time series. You can also see that in the collapse of the NBR, which is the burn ratio, also a composite of images, and you can clearly see that this changed a certain moment here in June. The same for cleared area and compared to forest. And for example, we also can see signals associated with seasonally flooded areas and with riparian forests. And these signals will be different from the signals of a stable forest or from the signals of the clear cut with bare soil or clear cut with fire. And so this is the whole time series where you have signals of time series associated with bare soil, forest, water, seasonally flooded, riparian, clear cut with fire, and so on. And we use sets to, we have the data cubes from the Brazil data cube, we get the time series, we have the training samples, we have methods for improving the quality of the time series, and this I didn't have time to show, but they are in the book, and to improve that, and then we get the deforestation data. And I'm not going to, and this is the final product and the comparison between what is being indicated in different classes of clear cuts with the image interpretation algorithm and what is obtained by visual interpretation. And you can see they're very close. So the application shows that it is, I mean, it's never perfect. And if you want to really say, it's not the case that machine learning will replace the human interpreters, and it's not the case that you can come up with the machine learning product and hand it over to your boss and say this is perfect. You always require cleaning and of course analysis and quality control. But in general, what we have found is that a lot of the work on visual interpretation is simplified because you get a heads up from the machine learning part. So, and the results in general are very good. Not perfect, but very good. I hope it answers your question.
Ibu En, it's clear. I think the application is very much clear how it can apply. We can see that it can identify deforestation, and then we can see the land use and land change dynamic, I think, from these cubes. So, Professor, I would like to deliver the question from the online participants. The first one, does land cover mapping from Brazil similarity if we compare data with Google Earth include time series, and how this map if we generate in the Google Earth, is this compatible both of them? Does land cover mapping from Brazil, I think the cubes is similar when we compare with a Google Earth engine. I think the question is about that. Does it is similar, and does do the both system is compatible each other when maybe when we want to overlay or something like a map, something like that?
First of all, we have made different experiments, but I think I showed you one independent work which was done by Indonesia here, the Indonesians, which clearly shows the difference between Google Earth Engine and time series analysis, and where time series analysis normally comes much better. It's simple. You use more data. The point here is normally when you take the mean on the Google Earth Engine, you are limited to the data, you're limited to the average of the data. You lose the time series information. So in general, having the time series compared to Google gives you a better result. In all the experiments we have made, this is clear. And the other thing, of course, to our users is that many users now are being charged by Google Earth Engine, but that's another issue. That's not the quality, but that's the money, in which they would have to pay and pay a lot to use, and then having a data set on the Brazil Data Cube helps them a lot. And the third question is, of course, you have much more flexibility when you have access to data, that you can merge data with different sources and so on. With Sentinel, we can merge Sentinel with Landsat, Sentinel-1 with Sentinel-2, Sentinel-2 with digital elevation models, and so on. You have a flexibility to use the data. So I think the compatibility, I mean, Google Earth Engine uses a language using JavaScript and Python. We have Python and R, but the commands cannot be the same. These are different designs and they work differently. So there is if you are really interested, on the online book, in the end of the online book, there is a side-by-side, if you want to compare, there's a side-by-side comparison with Google Earth Engine. And so you can take a look and see what you think. Okay?
Okay, thank you. I think that will be very clear. Other questions from Bobby, a researcher in Research Forest for Ecology. In the context of big data analytics, I would like to inquire if there are any established methodologies or best practices for obtaining stable, reliable, and consistent digital numbers, pixel values in raster data across long time series. Specifically, how can we ensure radiometric stability and comparability when integrating data from disparate acquisition systems such as Landsat and Sentinel? And furthermore, regarding urban development monitoring, are there currently any public access dataset available for nighttime light satellite, specifically those operated by China, that are comparable to existing global NTL systems?
Okay, so let's take step by step. Okay, so the first point is, what is analysis ready data? So I think that's a good point, because what is that, and I think we need to clarify this. Let's see. Okay. There is an organization called the Committee on Earth Observation Satellites, CEOS, and I believe Indonesia is part of CEOS. The Space Agency of Indonesia is part of the Committee on Earth Observation Satellites. And there is a set of standards established by the committee, so what they called ARD standards. Basically, what these standards say is what are the corrections, geometrical, radiometric, and atmospheric, that have to be put in place by the space agency to qualify as ARD. So they say that, for example, the images have to be georeferenced. They are aligned to a coordinate system. The images have to include shadow information, cloud information. And also, for optical sensors, the images are converted to what we call surface reflectance. So there is a difference between the light that the sun sent to Earth, and at that moment, they're reflected by the surface, forests, rice paddies, and so on. It goes up. Now, from the moment it goes up, there is a satellite up here that catches the data. Now, the satellite, when it catches the data, it might, for example, be a different satellite or the same series, Sentinel 2A and 2B, or Landsat 5 or Landsat 7. So, and that there might be some atmospheric noise here. So what you talk about, surface reflectance, is the images are provided not as they are acquired by the satellite, top of the atmosphere, but rather as they have been estimated as the reflectance of the pixel to a standardized sun. So even the inclination of the sun is taken into account from that canopy. So the same canopy would reflect the sunlight in two different satellites, will have the same response, the same surface reflectance. So the answer to the question of our collaborator here is that because analysis-ready data images are converted to surface reflectance, images from two satellites are comparable, images from the two satellites of the same series are compatible, images from different days are comparable. So this is what requirements that have been established by the Committee of Earth Observation Agencies set you to do. So at the moment I say that my data is ARD, I'm sort of guaranteeing that they are comparable over different years, for example.
Thank you. I think for me as a beginner, your explanation is much understood. And I believe our colleague who raised the question also clearly understood your explanation. And there's still more question, Professor?
Yes,
Yeah. In general, there are technical geospatial uses in tropical forest area, as well as methodological limitation, including signal saturation in dense forests, as satellite-based remote sensing is susceptible to noise, and optical signal saturation in dense tropical forests make it difficult to accurately capture land cover. And then limitation also about dependence on field calibration. The resulting modeling is not always 100% accurate without ground truth data, which is very expensive and labor intensive in vast area like Indonesia. And then the second limitation is the combined data paradox. Combining multiple sensors such as LiDAR and spectral sensor sometimes result in cumulative errors if calibration are out of sync. So can data cubes, or have they already addressed these issues?
Well, if I understand correctly, there are a number of issues that have been raised there. First of all, is satellite calibration. As I explained, the analysis-ready data should be able to be, let's say, not require the user to worry about satellite calibrations, because the data which is delivered is calibrated. That's the satellite calibration part. Then there are the problems associated with tropical forest. Now, the problems associated with signals in tropical forest, they are different depending on the kind of satellite you have. If you have optical data, you have a certain amount of, the noise problem is not so strong. But if you have SA data, okay, now you have problems related, because the SA data comes sideways, you have problems, for example, when there is a place here and there is a mountain. For example, there's a problem here that you have to, and one of the issues is that images, SA data, for example, the recommendation, if they are radiometric terrain corrected. So if you want some data, you better use what we call RTC data, which is radiometric terrain correction. That said, there is no perfect land use, land cover map. However, it depends on what your level of requirements are. I don't know, you have to tell me what is the level. I ask you a question. What is the level of accuracy relative to quality analysis which is required for a land use, land cover map here in Indonesia? Now I'm asking you. Can someone please enlighten me?
Yeah, I think it's getting interesting. Is there maybe our practitioner here, our researcher here can make a direction board from Professor, and then now it's Professor Kamara asking all of us. And I hope someone can answer, because he already answered so many questions. So now, Mas Agil? Yeah. Mas
if it-
Agil, maybe you can stand up so everybody can
Alright.
see you clearly, and also Professor.
Okay, cool. Yeah, if I'm not mistaken, there are no definite, I guess, threshold for a certain accuracy to be considered compatible for a certain analysis, but I guess the rule of thumb of general uses will be 85% of overall accuracy is sometimes suitable to be considered useful for, I guess, post-processing or the uses of that certain map. But if I'm not mistaken, that rule is for a certain application only. So in more general term, there is no, if I'm not mistaken, there is no, I guess, definite threshold for a certain quality of a map. That's my answer.
Any additional? Yeah, please, Mas Catur.
Yeah, thank you. Maybe I just add some information that how Indonesia produce land cover mapping. Actually, processing for land cover mapping in national case, the first support by National Research Agency to provide satellite data and pre-processing, and then go to Ministry of Forestry to make the classification. And currently, I think Ministry of Forestry combine with automatic and visual interpretation. So in this case, I think in Indonesia still have the problem with the consistency related with land cover classification. And I know in this currently support by FAO to do for uncertainty analysis about the change of the land cover for supporting the reporting from for climate change, for example, for REDD plus result-based payment. I think this just add the information. Thank you.
Thank you. Maybe some additional comments or discussion to add, Mas Catur and Mas Akil. Maybe Mas Doni or Mas Budi, I know they play with the maps and images. Is there any additional comments? Okay. So you may ask
Okay, so
more question, Professor.
I think the two answers is fine. They show that there is a practical threshold of quality and versus time that takes and cost and so on. And what we expect, okay, let's put it this way. Let's look retrospectively a little bit. Let's go back 20 years in time. Maybe you're not born 20 years ago, but I was born many years ago, 15 years in time. What you had as available were very few images, and you had to do a lot with these few images. Now, there's much, much more data being available. As more data becomes available, your possibilities of improving the quality of the maps improve. We are not in the end of anything. We are on a certain growth phase of data availability, which if it continues, will increase the number of satellites available, the number of data available, and the quality of what you get out of it. So that's very important. And I don't think that we should say, oh, it's never going to be good. It's never going, no, it's not. I mean, some of the questions, but you cannot do this, you cannot do that. Yes, that's true. But you do nowadays in 2026 much better than we did in 2016, much better than we did in 2006, much better than we did in 1996. The quality is improving. One of the question that was asked, I forgot to answer, has to do with Chinese satellites. Well, I am someone who has been to China many times. I had the privilege of working with China in the development of the Chinese-Brazilian Earth Resources satellite. So I think there is still some ways to go for China, instead, especially on the data policy side. I think that has to do with issues of data policy insofar as the Chinese satellite data is not available. And I think they still have some homework to do in the analysis-ready data. Even if the data would be available, is it not clear that the data will be analysis-ready? So it's always the Chinese way of doing things, which we have to respect. It's another culture, another system, and another emphasis on technologies and so on. But currently, I hope that changes. But currently, it is not a given. We don't have Chinese satellite data available. And we wish we had. And in fact, the data from CBERS is available in the Brazil Data Cube for Brazil. Okay? But of course, the C part is not available, for free in China. But I have to be very respectful of China, of what they have achieved in this last 20 years. I've seen China, Beijing, and 20 years ago, and now I see it's a different place. So I think they will evolve, hopefully, towards a more open policy of data, which I think will be very important for everyone involved.
Thank you. I'm not more than agree than that one. I saw someone raise hand in the online platform. Maybe we can connect, Mas Lutfan, with Ibu Rini Rahmania. Ibu Rini Rahmania, can you hear my voice? Ibu Rini? Oh, so not afraid. So okay, I'm afraid that the last one is not our last question, Professor, because we still have some. From our researcher also in the online platform. Thank you for the interesting presentation. I would like to know more about the data processing and the result. How reliable is the random forest model and what factors influence its performance? Additionally, how did you perform the validation for both the manual classification and the machine learning classification? Based on your experience, which approach do you prefer for classification?
Okay, so now we're back to so let's start from the start. There are a number of machine learning algorithms and deep learning algorithms for time series. In this chapter in the book, I describe what these algorithms are. So essentially, I don't know if everyone is familiar with the random forest model, but essentially it's a decision. It's a lot of decision trees. So essentially, what a random forest does, it builds a lot of decision trees based on values, whether the NDVI is bigger than this, and then the AVI is bigger than this, and band 1 is bigger than this, then this must be water. And it builds forests like that, and it takes, to ensure some variability, it takes some input bands out of them so as to have some variability. What has happened over the years is that other algorithms have been developed, which I'll describe a little bit later. But in general, what we have found is that the random forest is very good to substitute. It's not the most precise algorithm. It's not the best in the sense of guaranteeing that you have the best result. It's a reliable method that gives you a baseline result. It guarantees that you don't have the, let's say, crazy results. Now, whatever algorithms you use, they only are as good as the data that you feed into them. One very important thing is that you need to feed good data into your method. You need to guarantee that to feed good data. Now, a little bit on the algorithms. There are other algorithms. So I don't know if you can see here this table. There are on the vertical axis. This is the result of, given 100 trees, what are the most important values for that particular data set. And thank you. So on top of the most important values, you see a number. I hope that people on the back can see. It's written NIR 17. This is a near infrared, the 17th value. Well, the 17th value in a series of 23, meaning that this is, in the case of this series, somewhere in July, because the series comes from August to July, or September to August. So this point here says, well, it's the 17th value. So it looks not at NDVI, it looks at all the time series of NDVI and selects the point of the series which has the most information. Perhaps it's the time when there is change in the method, because people say, okay, the forest was stable until June, and then there was a cut. And I can see that clearly on the near infrared, for example. So the random forest is reliable, but other classical algorithms that exist in machine learning literature include the support vector machine. I'm not going to describe it. The extreme gradient boosting, which sometimes gives better data sets than the random forest. It's a little bit more complicated than instead of building. The gist is random forest builds 100 trees or 200 trees separate, independent of each other. The gradient boosting machine builds the first tree, uses the result of the first tree to build the second tree, uses the result of the second tree to build the third tree, and so on. So it's different because it takes one tree after the other. In general, the results are not so different from the random forest. Then you go to a different kind of algorithms, which they use what we call deep learning. And deep learning is essentially neural networks with more than one layer. So essentially it's a neural network with more than one layer, 3 or 4 layers, which essentially all this whole issue of deep learning is essentially a way to approximate functions. But of course, you can build. This is the simple, what we call the simplest kind of deep learning machine layer perceptron. There are also some with temporal convolutional neural networks which are available. And there is the whole, let's say the ones which are even more common in the large language model literature, which are the attention-based models. Again, these are models, I don't think I have too much time to explain them, but I could later on after the lecture go into more detail. But they essentially take a sentence and try to understand the relations between the elements of the sentence. Now, when applied to time series, they take a time series and try to establish the inference between values in the time series. What has this cut here or this decrease on the NDVI has to do with earlier decrease or earlier increase of NDVI. And it calculates these weights to reflect that some of the information in the time series, some points in the time series are more informative than other points in the time series. So essentially they're not a panacea. They may produce and usually produce better results, but that depends on your training data. Essentially, the quality of your method or the result is completely dependent very much dependent on the quality of your. Bad training data whatever algorithm, will never give you a good result. I hope I answered the question. There is one more person who has Rini Hamanya.
Yeah. I think she's the one that raised hand in the online platform. So, Professor, I think we have so many questions, but we cannot accommodate all can be answered today and this time. So I hope later we can compile the remaining question that is not yet answered by you, and hope you don't mind to have some response if we compile the question and give it to you. So I think the question from Ibu Rini Rahmania will be our last question for you to answer, if you don't mind. So Ibu is that okay?
I have time.
Yeah, okay. Okay. So Ibu Rini, please can you open your mic and you can ask directly to Zoom platform that we use.
Thank you very much, Professor Henty. Good morning, Professor Kamara. Thank you so much for your enlightenment presentations. I'm sorry I cannot open my video because the internet connection here is very lagging. So I just want to confirm.
Ibu
I
Rini,
just
can
want
you
your.
please raise up your voice?
Oh, sorry. Sorry. I need to move to another spot. So, Professor Kamara, my questions is still relating to the first questions of these discussions. So I just need your confirmations regarding the issues of time series in Indonesia, time series image, where we have um, most of the time we have no time series or image captures in specific area in Indonesian coastals. So I'm working more on the coastal and marine area, especially in shallow water area in small island, which containing seagrass, seaweed or coral reef informations. So we really need this data to develop local and support national data. So for the aforementioned issue, kindly please enlighten us about the data availability in Copernicus database or another database. Is it really no captures of image on those areas, or it is a special image on those area, but we have to buy those commercial image. So I just need your contribution from that issues. And last thing, if you don't mind, I want to ask about the problem of the tree canopy stratifications. So could you please give us an example about these implementations, considering the dense and different ages and canopy heights observed in one specific area, like in Brazil or Indonesia, where we often face spectral signature mixing under one canopy area. Thank you so much, Professor Kamara and Professor Henti.
Please, Professor from
Well,
Ibu Rini.
these are very difficult questions, not very. Okay, I'm trying to understand it's a little bit that she mentioned about buying data, right? That she
Yes.
buys data.
We have a problem that images from similar site cannot be accessed or accessible. So sometimes it should be available by purchase or something like so. So maybe she asked about how.
Can you enlighten me? What kinds of data are you buying?
Yeah, Mas Catur, maybe you can answer. Maybe
What kinds of data?
For example, we need a time series, like a 3 decades time series change in the coastal area, because we want to observe the time change, canopy change in mangrove area. And surrounding this mangrove area, there are also shallow water conservation area, which containing seagrass, seaweed, or coral reef. But unfortunately, we cannot access those data because sometimes the image is blurring. So we don't understand whether is it really there are no image captures from Copernicus or other similar agency, related agency, or is it there are other image on those specific area, but we have to buy it commercially.
Okay. But I was trying, okay, thank you very much, but I was trying to understand which exactly data that you're buying. Are you buying radar sets, you're buying Cosmos SkyMed, what data that she is buying, do you know?
Copernicus, Sentinel-2 image?
No, you buy Sentinel-2?
No, I'm asking if there are no image in those area? Is it really there are no image, or we have to buy those
No.
image commercially?
No, wait, no. Okay. Now I understand. So let's make an exercise. Wait a moment. Okay. Okay. Does anyone have a number for? See, I'm. It's one of the military grid reference. What is it? I had it. MGRS. Okay, I think it's this. Okay, that's getting better. Let me try to answer, I hope to answer her question on a clear. Well, here's Indonesia.
Yep.
Okay.
Java Island.
Okay. So now, taking just the arbitrary here, this is very small. 49 MEN.
Professor
Okay.
Professor Kamara, if you don't mind, could you please move your cursor to the West Nusa Tenggara, because in mainland island and its
The
surrounding,
West.
yeah, we can get a clear image, but in the small
Huh?
islands, it is hard to
West
get a clear
Java.
image. West Nusa Tenggara, NTB.
East Java.
Yeah, this is Java. This is West Nusa Tenggara is small island. Further east.
So this is Flores? Was
Yes, in Saleh
which
Bay,
one?
Teluk Saleh, for example,
What?
Saleh Bay, Teluk Saleh.
Saleh Bay. Mbak, Saleh Bay di mana ya?
Ya, itu Bu, persis Bu di situ tinggal di zoom aja. Itu Teluk Saleh, udah bener di tengah itu ya, tinggal di zoom.
50 LNR. Okay. And where is the, just to get my sense, where is, just give me the most favorable time of the year to get images? Do you have? Okay, so let me do the following. So 50 LNR. This is going to take some time, but let's take it. 2025 0101 2025 12 30. So, does everybody see what I'm doing? Okay.
Yes.
LNR. Okay. So, it's not Brazil, but what is it doing? Yeah, it's doing something. Did it stop? No. Let me see. Oh, let me stop here. We're here with too many. Okay, 50 LNR. Okay. No. First of January, 31st of December with Sentinel-2. Okay. So it's going, what it's doing now, it's going from my machine to Amazon, and it's asking Amazon which images they have from 50 LNR cube, and it has okay, so let's see. So it has found 688 images with, but of course this is 4 bands, so let me see. Okay, so this is band 2, band 10, band 11, cloud cover. So the images are there, and in principle you can copy them to your machine. It's going to take some time, but now I'm just going to plot one image, the image with the least cloud cover. It's going to take a little bit of time, but you will eventually get there. So asking to respond to the question being asked, basically I can do whatever with the data. I can download, I can use that data, and I don't have to pay anything. I'm just going to plot just for the record, but I could copy that data. It's going, of course, it's a lot of images, 688 for the whole year, but it works. Now, of course, okay, so this is, let me show the zoom here. So this is one part of the image. You see a part of the island. Of course, it doesn't cover the whole area because this is a part, but I could, of course, complement that with other images. But reasonably well, I can see the data. I can ask access the data. So I just downloaded like this one image from Indonesia without any, no one didn't pay. You didn't see showing me my credit card or anything. So it's there. So I don't know if the lady still has questions. So that's it. So it's a question of putting the data down and working with it. Of course, if, let's say, it's clearly it would be easier if, for example, an organization like BRIN would have its own cloud service. Okay, and then of course you don't have to go to Amazon, you go to BRIN and get the data, but the principle is the same. Of course it would be faster to get it from BRIN than from Amazon, but the idea is the same. Ask her if it answered her question.
Mbak Rini, apakah...
Yes, thank you, Professor Kamara. Actually, we are now working on a 3 decades multi-time series image on this area, and we found some not good enough image or missing image, but due to this limited time on this discussion, I would like to asking your permission to kindly connect it to your GitHub to discuss more about it. Thank you, Professor Kamara, Professor Henty.
Yes, I'm available for discussion. Please take note. Okay, so let me just, before I forget, where is it?
Maybe you can provide your email?
Yeah, I have email, so please.
we have almost 450 person in our online Zoom meeting, Professor. So everybody very enthusiastic, I think. Yeah.
So please take note of my email. And of course, I'll be available to discuss and talk to you. And maybe if you bring needs, I can host, if you want, further up other, for example, an online seminar that we can arrange if you want. I'm available. It would be my pleasure to do so. So this is the GitHub and the email. So I'm available, and it will be a pleasure to work with you.
Okay. Thank you, Professor Kamara. I think everybody can make a note for his email contact.
Yes.
So, yeah. And I think one more, Professor, because it's already written here, from Bapak Nurmianto. Is there an advanced remote sensing technology or novel approach to mapping agroforestry with obstacles such as boundary line with primary forests, deforestation issues with AUDR, geotagging to determine main commodity population such as coffee, cocoa, etc. with multi-strata canopy condition, majority in sloping land, and also to assess land degradation? Thank you.
Okay. Well, this is a tough one. So I'm going to show you what we did recently. So one thing we did was, let's see if I have it here. Right. Okay, so one thing that we are doing is, this is the tough one. What essentially, if I understood the question, the question has to do with the ability of using satellite data to separate between different kinds of cover, which looks like tree cover. So you have native forest, you have agroforestry, and you have perennial agriculture. In Brazil we call it perennial cocoa, coffee. These are trees, but we call them perennial agriculture. And then there's a fourth one in Brazil, which is very common, the semi-perennial agriculture, which is sugarcane. Okay? And it's tough. I can tell you that we've done it we've just finished the product comparing 25 years of data. And here we map perennial agriculture, we map semi-perennial agriculture, we map silviculture. Silviculture is agroforestry, but in Brazil, what we don't have so much palm oil, but we have mostly pinos and eucalyptus for pulp, for cellulose. But we managed to get reasonable results. When I say reasonable, I don't, let me see if we have, this is, I can send you, those interested, the link, but it is, my point is, it is extremely tough and it's not easy. You need good ground data, essentially, to start with. And with some quality, you can separate agroforestry from forest. We found out that agroforestry is easier to separate than perennial agriculture. Perennial agriculture is even for let's say 10-meter satellites with Sentinel, it is not easy. we have this, and there's a place where you want to go to. There's an official data which we use in Brazil, which is used as time series, Terra class, which is classification of terra is in Portuguese means land, and come on, it's just that it takes some time. Interactive map. So here we have some of the results of this. It uses for the retrospective we use Landsat. For this official data we use Sentinel. It's taken a little bit of time, but it's coming. But the end result is the uncertainty of the forest itself, the tropical forest, is quite good, so low. Then in terms of complication, the semi-perennial, if we use a good time series, is also good. Then the agroforestry, and last, the perennial. The perennial agriculture is where you're lucky to get 70% right. It's tough, right? Because there's so many, I mean, when you talk about cocoa, for example, in Brazil, which cocoa are you referring to? The open air cocoa, the cocoa at the mixed forest? So, I mean, some types of cocoa, especially if they mixed with native forest, I mean, make no mistake, they are extremely tough to get. Didn't I get this mapa interativo? Yeah, so this is what you get. So you get this map, and then your iterative map, and you get the different classes. But really, to be honest, some of the areas of perennial agriculture, I mean, the big plantations of sugar, of soybeans and so on, they're easy. But perennial agriculture remains a problem. Okay.
Thank you.
I answered it.
Thank you, Professor. I think that's very clear for your explanation. So I think it's already, time's already up. So every question that not yet answered will be compiled, and please, we will send you a letter. So after we complete this session, I would like Ibu MC, so I would like ask Mr. Ping to conclude. Okay, in the end of this session, I would like to ask Bapak Ping to make a concluding remarks or wrap up our discussion. So please, Bapak Ping, come, and the stage is yours.
Terima kasih. Thank you, Ibu Hetty, the moderator. Thank you, ladies and gentlemen. I think it's very refreshing that the discussion was very technical. I think it started with a broader understanding. You know, you tricked us into thinking that it's the first few slides was about the satellites and everything, but then very quickly we go into even the codes and everything. So that was very refreshing. I think it's one statement that was left a big impression for me, is that we do now live in the age of the big Earth observation data set. Petabyte is not something we see very often. Terabyte is already impressive. Now we're looking into petabytes every day. And I think this is an opportunity to really address what we have very long identified as a key characteristics in places like Indonesia, which is heterogeneity. So unlike other places of the world, industrialized areas, for example, land use activities are relatively homogeneous. I think in the tropics, similar to Brazil, Indonesia as well, I think heterogeneity is something that is a key characteristic. Different areas at different time period will have very different activities that requires very different treatment to identify, especially from an Earth observation data perspective. And technology such as SITS allows us to go into the next level to allow us to incorporate and address this heterogeneity in a more objective way, in a more data-based or evidence-based way, instead of subjective observation and description of something that is very complicated. At the same time, it also opens a new field of methods and methodology, that is how to treat the data. You mentioned a lot about how to, it sounded simple, how to organize the data both from a spatial and from a temporal perspective, but there's actually a lot of details being involved that requires, I guess, a lot of new things. Requires new things to learn and technical issues to then solve together. This also then brings additional opportunity of DataCube, not just as a data treatment concept, but also, I guess, Pak Kapus, as an opportunity for future collaboration, I would say. I think DataCube, well, a lot of things are available already at the moment, but of course, BRIN as the authoritative, research agency in Indonesia will then be very well positioned to be housing a DataCube that is very specific to the needs and to the relevant topics that those working on topics related to Indonesia are concerned with. So I think this presents like an evolution of understanding that the addressing of the opportunity that arise from a technology and a new approach based on that technology brings a new opportunity to address and solve what is ultimately a real life challenge that we need to be addressing. So yeah, I think it's very encouraging to see the technical interactions that are taking place with the participants, both online and offline here in Cibinong. And it's also refreshing, at the same time encouraging, to see that it leads to new questions. There were a question about what would be the threshold for accepted quality, accepted accuracy, for example. Something that we later on found out is not necessarily something that we have properly addressed. I guess it has something to do with the fact that a lot of the agenda, for example, on the usage of the data, Wahyu mentioned about RED Plus, for example, for different climate change initiatives are not necessarily a demand that comes organically, intrinsically from a national needs perspective. So I think this is one example how, you know, one solution leads to new question. Hopefully we will solve it in the future, but this shows exactly the spirit that we would want to achieve by putting data at the core of the initiative that we are doing. Data is an enabling condition that enhances our understanding and therefore our ability to address ultimately real life challenges coming from nature-based climate solutions. So I think I will stop at that, Ibu Moderator, in trying to share my contemplation, other than my confusion on the technical bit, which I'm happy that I'm confused at least. But yeah, I hope it inspires future activities and future collaboration. So, terima kasih, Ibu Hetty. So, back to you.
Thank you, Bapak Pings. Very meaningful closing remarks from Bapak Pings. So we have reached our end session for this expert talk. So I would like really say very much thank you for Professor Kamara for your insightful presentation and your brilliant experience for us. So also thank you very much for all the participants for very active engagement in this discussion. I hope this session will bring us a new perspective and also enrich us with innovation and other out-of-the-box thinkings that can be a solutive for our problems in this country, of course. So to move to the next segment, I would like to give us the floor back to Ibu Afi as our master ceremony. But before that, please have a big applause for all of us. Thank you very much.
Thank you, Ibu Moderator. Ladies and gentlemen, that concludes the discussion and deep dive session. Once again, we would like to express our sincere appreciation to Professor Gilberto Kamara, Dr. Pingy Wargana, and our moderator, Ibu Henti Handala Suti Rahmat, PhD, for the insightful discussion and valuable knowledge shared with us today. Ladies and gentlemen, both on-site and online, please give them a round of applause. Ladies and gentlemen, before we proceed to the closing remarks session, we would like to continue the presentation of appreciation to our collaborating partner from IIASA and C4 iCraft World Agroforestry for their valuable support and collaboration. May we kindly invite Dr. Pingy Wagana from IIASA Epistem Coordinator and Bapak Andre Ekadinata from C4 iCraft World Agroforestry to please come forward. We would also like to invite Bapak Asep Hidayat, PhD, to present the appreciation. Thank you. Thank you, Bapak Asep Hidayat PhD, Dr. Pingy Wargana, and Bapak Andre. Ladies and gentlemen, we will now proceed to the closing remarks session. To officially conclude today's scientific seminar, it is our honor to invite Bapak Asep Hidayat PhD, Head of the Research Center for Ecology BRIN. Please welcome Bapak Asep Hidayat PhD.
Okay, thank you, Ibu Afi from the time. As the closing remark, maybe I would like to say thank you from Professor Kamara, from your good insight to us, good experiment and share your knowledge to us also. And this is maybe will give us like initiative or some idea to do something in the future. And then also I would like to say thank you to Bapak Ping, and then also Mas Andre. Thank you very much for your good cooperation with the institution. Of course, I would like to say thank you to Mas Doni as the project coordinator project from Epistem in Indonesia. Thank you very much. And then team from the ICRAP, I would like also say thank you very much for your good cooperation. And all audience in online and offline, especially from our researcher, for Research Center for Ecology. I would like to say thank you very much for your attended, and you give more question to increase or give insight to us. I would like to say thank you very much. And then I hope after this event, expert talk in the first expert talk in the 2026, we have give us the opportunity to make good cooperation, not only between the researcher in the BRIN, but also you should have more cooperation with another institution, not only in the Indonesian institute, but also in the broad institution like the Brazil. Maybe after Professor Kamara give me an email to us in the PowerPoint, maybe later you can make the contact to him to make deep discussion, and maybe probably we can good cooperation later, make the project together, what can do in the Indonesia to increase the hours, something like the research. And then of course all the organizer committee from the expert talk, I would like say thank you very much. From your organized is very well, and then I hope it's not the end of the expert talk, because in this year we have still 2 or 3 again the expert talk. Maybe later we can do more best after this expert talk. This is maybe my closing statement. Thank you once again. Thank you very much for all of us. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Bapak Asep Hidayat PhD, for the closing remarks and for officially concluding today's seminar. Distinguished guests and participants, we have now come to the end of today's first expert talk. We hope this event has provided valuable insights, strengthened collaboration networks, and encouraged further development of reproducible and science-based landscape monitoring system. On behalf of the organizing committee, we would like to express our sincere appreciation to our distinguished speaker, the moderator, institutional partners and collaborators, and all participants, both on-site and online, for your active participation throughout today's seminar. We also apologize for any shortcomings during the event. I am Restuna Rafiati, your Master of Ceremony for today. Have a pleasant day. Enjoy the networking session. See you again at future events. Thank you very much for your kind attention. Bapak Ibu, panitia telah menyediakan